So these are the oxygen tanks that we use in our hospital. They're called H tanks. They're filled with liquid oxygen. It says liquid air on here at the top. And then back here is where we turn them on. So when they're full, it's up to 2,000 PSI. And then on the side of the tank, it tells you how many liters come in the tank. So after looking at the oxygen tanks that we have in the clinic, you can determine the concentration or the molarity of a gas by looking at the pressure, volume, and temperature by using the equation PV equals nRT. On the oxygen tank, it tells us that when the tank is full, the pressure is 2,000 PSI, which after our conversion factors comes out to 136 atmospheres. The volume was on the tank, and that's at 7,100 liters. And liquid oxygen is a cryogenic, which means that the liquid is maintained at a temperature below freezing. Oxygen tanks are typically kept at negative 297 degrees Fahrenheit, which after converting is 90 degrees Kelvin. So now that we have all of our numbers, we can insert them into our equation and solve for n. So this is what our equation looks like. You have n equals PV over RT. And after solving, we get n equals 965,600 over 7.389, which turns out to 130,680.742 moles of oxygen inside of a full tank. And if we look at the avocado, we can tell that pressure is directly proportional to the number of particles. Yeah. So now we're going to do some significant figures. I'm going to use my friend Twinkie here, and we're going to see what she weighs today. So go ahead and follow me over to the scale. Okay, so she weighs 8.590. And the medication that we're going to use today as an example is Lasix. It's a diuretic used for patients who are in heart failure, and it is a 5% solution. So I will go ahead and work out the problem on how to get her dose. So now that we weighed our patient and we have our concentration for our solution, we're gonna work out our problem to determine how many mLs our patient needs. Our first step is converting from pounds to kilograms. Then we're gonna have the percent and convert that into grams and then into milligrams. And then this is our dose, 2 mg per kg will equal our dose. Then we're gonna divide that by our concentration, the percent, in milligrams, and that will give us how many mLs to give our patient. So our patient weighed 8.590 pounds. The 0 is significant because it is a trailing 0 after a decimal point. Converting pounds to kilograms, there are 2.2 pounds per 1 kilogram. So we're going to divide our weight by 2.2, and that gives us 3.9045 kilograms. And our Lasix is a 5% solution. So this means that there is 5% furosemide per ml. So if we convert the 5% into a decimal point, it's 0.05, and that is grams. And there is 1 gram per 1,000 milligrams. And we need the milligrams because our dose is in milligrams, it's mg per kg. So we're gonna convert this and multiply this across to get our milligrams. That gives us 50 mg per ml. And our dose is 2 mg per kg. So what we're gonna do is multiply 2 mg per our kilograms. So our patient needs 7.809 milligrams. And then finally, we're gonna take that milligram dose and divide that by our concentration, that 50 mg per ml that we got up here. So after we divide our milligrams to get our mLs, we end up with 0.1562 mLs. We have 4 significant figures in our final answer because we started with 4 significant figures from our starting number.